Welcome back, everybody. In this video, we're going to start taking a look at simplifying fractions using the fundamental property of fractions. So before we get started, I did want to mention that the process of simplifying fractions also goes by the name of reducing fractions, and I'll talk about that a little bit more. So here we're simplifying and reducing fractions. So the first or next and most important thing to do really is to talk about the fundamental property of fractions. The fundamental property of fractions reads here. And when we say fundamental, we don't mean fundamental as in easy on this. Here we mean fundamental as in important. This rule about fractions is one of the most important rules in dealing with fractions. And here's what it says. Here we're using letters to stand for numbers. If that's not so familiar to you, you're going to get more familiar with it. You can just think of, in this case, A and B and K are representing any numbers you want, as long as B and K are not zero. So this is just a use of variables or letters to show a pattern. And here, A, B, and K are any numbers of your choosing as long as B and K are not zero. And here's what it says. On the left, we have A times K divided by B times K, or in other words, a fraction with AK in the numerator and BK in the denominator, that is equal to or is equivalent to the fraction A over B. And then the second part of it says, if you have a fraction with A divided by K in the numerator and B divided by K in the denominator, that is also equivalent to the fraction A over B. And the equality in each case can be read left to right or right to left. So you can look at it and going left to right or right to left. So what this says more in plain English is that you can multiply or divide the numerator and denominator of a fraction by a non-zero number without changing the value. So let's see some examples. All right, so for a couple of quick examples, let's say we have the fraction 3/4. If I were to take and multiply in the numerator by 10 in each case, or in the denominator by 10, I should say. Okay, I've multiplied both the numerator and denominator by 10. In other words, the K is 10 here. In the numerator, we'll now have 30, and in the denominator, we'll have 40. Okay, we've multiplied the numerator and denominator by 10. Okay, let's do another example. Let's do one where we divide the numerator and denominator by something. So let's take 10 45ths. So 10 and 45 are both divisible by 5. So let me make that color. So we're going to divide 10 by 5, and we'll also divide 45 by 5. 10 divided by 5 is 2, and 45 divided by 5 is 9. And so the point of the fundamental property of fractions is that 3/4 and 30/40 represent the same part of a whole, have the same value. 10/45 and 2/9 have the same value or same parts of a whole. Okay, remember how we talked about with fractions, there are many, many ways of representing the same value. The fundamental property of fractions, which I'm going to be abbreviating by FPF, tells you how to change from one form to another. So it's really important. It's how what we use to simplify fractions, and later we'll be using it for something else called building up fractions. So that is the fundamental property of fractions, and we're going to use it to help us simplify fractions. So that's the part that is next. So this part is on writing fractions in simplest form. Fractions that represent the same value, that is the same part of a whole, are called equivalent fractions. They're equivalent. Some people say equal. It's more common to hear people say equivalent. They're equivalent fractions. Fractions are in simplest form if their numerator and denominator have no common factors other than 1. The phrase in simplest form is also referred to as simplified. We could talk about a fraction being simplified or reduced. okay, or in lowest terms. So there's a lot of words for the same thing. I typically avoid using the terminology reduced because that sounds like something actually has gotten smaller, and we don't want to, our fractions to change value. For example, if you have the fraction of 10/20ths, an equivalent fraction to it is 1/2. They're both equal to a half. And you could say, okay, well, you reduced that fraction. But the word reduce in English means to lessen something. Like if you go to court and get your fines reduced or something, then they've decreased it. Okay, so the word reduce kind of connotes decreasing the amount. And an important fact about these two fractions is that they represent the same value. We haven't changed how much one is worth by referring to it as 1/2 instead of 10/20ths. So I won't be using the phrase reduced very much, but you will see it out there. Simplest form, simplified, or in lowest terms. Okay. Some examples of fractions that are simplified and some that are not. In the top row, these are not simplified. Let's take a look and see if we can tell why. 10/24ths, 10 and 24 are both divisible by 2, and so they have a common factor of 2. And so that's why I'm going to write CF for common factor. Okay, there's a common factor of 2 in the 10 and the 24. 9 and 51, this one's going to be a little bit tricky because 51 is going to look prime to you, and that's okay. But 51 is actually divisible by 3, right? So 9 and 51 both have a common factor of 3. So that's not simplified. Okay, 84 and 90, again, both of these are even, and so there's a common factor of 2. There may be other common factors, right? But as far as this, just deciding is this fraction simplified or not, if there is even a single common factor besides 1, it's not simplified. Okay, 64 and 28, that has a common factor of 4, so that makes it not simplified. Okay, a couple of fractions that are in lowest terms are simplified. 31 and 49, 31 is prime, so its factors are only 1 and 31. 49 is 7 times 7, right? And so these don't have any common factors. Okay, 50 over 27, it's negative, but that part doesn't matter, okay, in our discussion of whether it's simplified or not. 50 and 27, 50 has factors of 2, 5, and 5. 27 has 3 factors of 3. They don't have any common factors, so it's simplified. 3/5, both 3 and 5 are prime. It's a simplified fraction. 12/17, 12 is 2 times 2 times 3, and 17 is prime. And so this one is in lowest terms or is simplified. Typically in this course and in virtually all math courses, you want to give answers to fraction problems in simplified form, that is in lowest terms. So develop the habit of simplifying your fractions kind of automatically, unless some direction words tell you otherwise, to leave a fraction as unsimplified. Later on, we're going to see how to unsimplify fractions. How to write a fraction in simplest form, now that we know what simplest form looks like. To write a fraction in simplest form, you find the prime factorization of the numerator and denominator. That's why we did prime factorization, is because of this. To find the prime factorization of the numerator and denominator, then use the fundamental property of fractions, or FPF, to remove all the common factors. So let's try it. So we want to simplify 98 over 50. So let me begin by finding the prime factorization of 98. 98 is 2 times 49. 49 is 7 times 7. So that's 2 times 7 times 7. 50's prime factorization is 2 times 25. 25 is 5 times 5. So the prime factorization is 2, 5, 5. All right, so now the fundamental property of fractions tells us that we can divide or multiply the numerator and denominator of a fraction by any value we want, And so here we're going to divide the numerator and denominator by a 2. So I'm dividing that out, and the way that we show that is by crossing out the 2's. All right, so now that we've divided the numerator and denominator by 2, what is left is in the numerator 7 times 7, or 49, and then in the denominator 5 times 5, or 25. So at the end, we are left with 49/25. Okay, let's try that again. Here we have 5/50. 5 is already prime, so we're just going to let 5 be 5. For 50, 50 is 2 times 25, and 25 is 5 times 5. So that's 2 times 5 times 5. And so then from here, we're going to divide the numerator and denominator both by 5. 5 divided by 5 is 1. 5 divided by 5 is 1. And so what's left in the numerator is a 1. And then in the denominator, 2 times 1 is 2, times 5 is 10. So we have 1/10. All right, so this next one, take a minute and pause the video and try this yourself, and then we're going to go through it together. All right, so let's try again. So we have 35/75. So we need to find the factorization first of 35. So 35 is 7 times 5. I like to write my numbers in ascending order. That's why I put 5 times 7. 75 is 3 times 25, and 25 is 5 times 5. So we have factors of 3. I did them out of order, 3, 5, and 5. Okay, so then using the fundamental property of fractions, we'll divide the numerator and denominator by a 5. And that's it. There's nothing else we can divide out. So we're left with 7 in the numerator, and then 3 times 5, or 15 in the denominator. All right, so we've started out with just a couple of smaller fractions with this. We're going to do more in just a few moments, some that are more sophisticated, but I wanted to start with some examples where it's smaller just to illustrate the process. Before we go any further, I did want to mention that you really want to be careful with the fundamental property of fractions and applying it to simplify fractions, and as we'll see later, building up fractions, because it's common for people to mess this up. And students through beginning algebra, trigonometry, pre-calculus, calculus, still basically kind of mess this up from time to time. So the sooner you get a handle on it, the better off that you will be. The two most common mistakes, just so that you can try to learn to spot them, are, for one thing, failing to simplify completely. In this case here for A, we've started off with 24/30, and then perhaps recognize, okay, well, there's a common factor of 2 that can be removed. 24 divided by 2 is 12, and then 30 divided by 2 is 15. However, and those are equivalent, which is true, but virtually always in math classes, we want to simplify completely. And 12/15, the 12 and 15 both have a common factor of 3. So we just didn't simplify all the way. So that's a common error. Okay. The other common error is failing to divide by the same value in the numerator and denominator. When we saw the fundamental property, there was a k on the top and a k on the bottom. It's the same number. What went wrong here, 6/20 and 3/5, 6 gets divided by 2 to be 3, but 20 got divided by 4 to be 5. And so that's wrong. 6 divided by 2 is 3. 20 divided by 4 is 5. 2 and 4 are not the same. Okay, that's what's wrong with it. You need to multiply or divide the top and bottom by the same number. So 2 common mistakes, just not going all the way with it, and then multiplying or dividing by like 2 different things. So try to keep your eye out for those mistakes so that you're less likely to make them. All right, so that takes us to the end of this first video on simplifying fractions. In our next video, we're going to focus really on examples. Okay, until then, let me know if you have any questions, and then have a great day.